Hello everyone. In this video, we would be solving CM1 Paper B for April 2022 attempt of IFoA. Let's start with question number 1. So this is a profit testing question. A life insurance company issues 25-year unit-linked policy to a life aged X exact. The profit vector for the policy and the relevant assumptions used to perform the profit test on this policy are given in the question 1 worksheet. Determine the reserves required at the end of each year to zeroize the future negative cash flows for this policy. First, we need to determine the reserves required at the end of each year. So not at the start, but we need the closing reserves, not the opening reserves. So let's see. This is the base sheet which is given to us where we have been given the non-unit cash flows and we have been given the probability of being in force at the start, at the end of the policy year, given policies in force at the start of the year. Basically, PX is given to us. Risk discount rate is given to us and rate of interest on unit fund is given to us. So basically, for all calculations, we'll use 4% and only for calculation of expected present value, we'll use 7%. Let's come to question 1. So we have this 2 columns were given and we need to fill these. So what we have done is just equals to the base worksheet, both of them. Then reserve required at the end of the year. So since we need to zeroize the reserve, first starting, since this is closing reserve should be year end. Closing reserve is always 0. So we'll start from here. When we start from here, what is the formula that we are using is if C31 is less than 0, that means if our cash flow, the last cash flow is less than 0, that is if it is negative, then what we do, we take the maximum of the reserve into the probability minus the cash flow and we divide it by the non-unit fund interest rate, that is 1 plus 0.04. Okay, otherwise if it is greater than 0, then we want it 0. Okay, and we zeroize these. So all the negative cash flows over here are calculated. These are the closing reserves. For once getting confused, what you can do is make a column on the opening reserves here and just starting reserves is 0 and opening reserves for these will be these. Okay, for calculation of profit vector, one can do this. Then CIR, cost of interest on reserves, is nothing but the reserve at the year end into the probability minus the opening reserve into the 0.04, which is the interest rate. Okay, so once we get this is the cost of interest on reserves, and then profit at year end is nothing but opening reserve, non-unit cash flow plus opening reserve minus the cost of interest on reserves. This is reserve, we drag it till the end. So we see all the negative cash flows. If you see, all the negative cash flows have been zeroized over here wherever required. See, wherever required, all the negative cash flows have been zeroized and all positive cash flows have been brought into here. Okay, adjusted for. So now survival probability at year 1, it will be 1. From next year onwards, it is 1 into probability in force and dragged it down till bottom. Then we have the discounting factor, which is nothing but 1 plus, now we will use 7%, 1 plus 7% to the power minus of time, and present value of profit vector with no reserve. So with that will be only cash flow into survival probability into the discounting factor, and with reserve will be the profit at year end into survival probability into discounting factor. Once we get these, we can do the sum of both the columns and this will be our answer. If you see that with reserve, without reserve, we get a profit, whereas with reserves, the company is experiencing a loss. Okay. Then we have done calculate the present value of profit. So first part and second part is done. Discuss the impact of profits for this policy on setting up reserves. So if you see that with reserves, it's a negative impact, with without reserves, the positive impact. Then since we have after the major impact is caused in the first year, if you see all other are almost same if you compare, but only in the first year, since after reserves is kept, the without reserves the cash flow is positive, so present value remains positive, but after keeping reserves a major chunk of the non-net cash flow is put into the reserves, hence the present value of profit with reserve becomes negative, which causes the major difference in the uh, net present value. And also the reserves are calculated at 4%, whereas profitability is calculated at 7%, which will cause a major impact on these well, answers. And then you can just put your answers over here. Moving forward to question 2. The question 2 worksheet contains mortality data and other assumptions used by life insurance company for pricing assurances and annuities. Calculated the expected present value of a revisionary annuity of 10,000 per annum payable annually in advance, starting immediately on death of a female currently aged 62 exact to a male currently aged 63 exact. So basically we need to calculate a revisionary annuity, and again we have been given our base in the worksheet. So we have been given LX, TX, LXA for both male and female, and we have been given the assurance percentages and annuity percentage, and some assumptions are given. Okay, so for question 2 part 1, if we see, we have annuity. So for annuity, if we calculate, again this was supposed to be calculated QX, PX, QX, QY, PY, and then what we have done is first we need to take the percentage data for annuities, which is given over here, which is 85% for males. So multiply 85% into dx by lx, which gives us qx, and px is nothing but 1 minus qx. Similarly, for females, we have 75% into dx by dy by ly, and here again 1 minus qy will give us py. And for the last, we'll drag the formula still here. For the last, it is said in the question that for both males and females, probability of death at age 100 is assumed to be 1. So this has to be 1 and not any percentage, and the both other will be 1 minus 1, which is equals to 0. Now, they've told us to calculate the EPV of a revisionary annuity. So let's take from, since annuity, it's payable in advance. So we take time from 0 to 37, which is, it's a whole life annuity. So it's 863 to 100. And this will go from 862 to 99, whatever. And this is 0 to 37. We take out TPX, which is 1 in the first year, and for next year onwards, it is nothing but 1 into VLOOKUP of 63 from this table, okay, which is from the 7th column PX value, and for each of the years it is calculated. Similarly, TPY is first year 1 and second year onwards, it is this into VLOOKUP and 11, this comma 9 comma 0. Once this is done, we can calculate TQY because it's a revisionary annuity, and it says that immediately the death of female. So female will be 1 minus this. Discounting factor is nothing but 1. Discounting factor is nothing but 1 plus the interest rate given to us at a 7.5%. Sorry, 4.75% over here to the power minus of time. And once that is calculated, for all the years, we get the EPV, which is nothing but 10,000 into TPX into TQY into discounting factor. And once this is calculated, we get the value, sum of all this, 12689.33. For question 2, part 2, we have been told to calculate the probability that a male annuity holder currently aged 56 exact dies after a female annuity holder currently aged 61 exact. So we this is the there's no EPV, but there's a probability where we have to find the situations wherever the male aged 650 male will die after the female is dying. Okay. Male will die after the female dies. So here again, we can fill this table. So it is the same thing since it's an annuity holder. I've just equated it to the previous sheet. Do not need to calculate again. Now age of X is 56 year and 61 year. It goes up to 100 wherever required. Here we do not need till since female is reaching 100. So after that we will not require probabilities. Now what we are doing over here is we'll first find the probability of male being alive, then the probability of female being alive, and the probability of female dying. So once female dies, after that, at any point of time male dies, that probability will be taken incorporated into account. Okay, so that is why we are here. First, we are assuming that female dies and then male remains alive. So will give us the probability that male will die after the female. Okay. So TPX is again 1, and similarly we are calculating using the VLOOKUP function 1 into this, and this will go up multiplying cumulative probabilities. Similarly for TPY, and QY plus T will give us that where will the female die for that year. Okay. Now probability is nothing but initially at age 61 female is alive, and then for that year male is female is alive and she dies in the next year. Female dies from age Q61 basically, and male is still remaining alive. Okay. Then again, female probability of female being alive for 1 year from age 61 to 62, then dying at age 62, and then male being alive at age 58 after 2 years. So this is how we'll proceed, that how will male and female interact. So probability of female being alive till the point of time into probability of for it to die into probability of male being alive at that point of time, and summing this up will give us the probability that male will die after the female. Okay. Now question 2 part 3 is calculate the expected present value of a 30-year last survivor term assurance of a 100,000 payable immediately on death for a male currently aged 27 exact and a female currently aged 25 exact. So now we have an assurance value. So we have the base worksheet where we have been given percentage data for assurances. 95, 19, 5.25%. So we'll use those bases to calculate the QX, PX now and QY, PY. Now time, since it's immediately on death, we'll take from 0 to 0.5 to and when it will go up to 29.5. Here you can see 0, 1, 2 if you want to specify here, otherwise it's not required. Then we have age for male starting from 27 and age for Y starting from age 25 till 55. We have discounting factor, which is nothing but 1 plus Q2 to the power time and into 0.5. Then we have the TPX again 1, and we look up depending on the age again. And similarly, now we'll calculate QX. So for the assurance factor, if you see, since we know that the assurance factor is VQX plus V square PXQ x plus V square 2PXQX plus 2. We'll use this concept over here. So first will be VQX, then will be V square PX into QX plus, and then will be VQ 2PXQX plus 2 over here. Just writing it clearly. VQX plus V square PXQX plus 1 plus VQ 2PXQX plus 2. Now, since here it is immediately on that, you can see to the power 0.5, V to the power 1.5, V to the power 2.5. so on. So we'll use this concept for calculating assurance factors for X over here now. So basically, A bar X becomes V to the power 0.5 into TPX, which is initially 1 into QX, and similarly, and drag down this formula for each of the years. Similarly, we'll do the same thing for TPY. We'll calculate TPY, we'll calculate QY, and then we'll calculate A bar Y, which is same. V to the power 0.5 into TPY into QY. And then we'll calculate TPXY and QXY. TPXY is nothing but TPX into TPY. QXY is nothing but 1 minus PXY. So we have to calculate PXY. Now what is PXY? Is 1 minus QX into 1 minus QY. So 1 minus whole of this multiplied will get QXY, and then A bar XY is nothing but again V to the power 0.5 into TPXY into QXY. Okay. Once we get all these assurance factor, we'll take a sum of all these. And now we have to calculate the last survivor status, which is nothing but A bar X plus A bar Y minus A bar XY into 10,000, 100,000, which is the sum assured. So 100,000 into A bar X plus A bar Y minus A bar XY. This is the EPV of a last survivor status of our male and female given in the question. And then we can populate the answers which we have calculated over here. Next, we have question 3. This was the most difficult or time-taking question for students, as they found out. This was not difficult, I would say, but it was time-taking, as all the payments were given in quarterlies or half-yearlies or monthlies, and they had to make an annual cash flow according to this. So let's just do this question part by part. That will only help us. So it's given that a piece of land is available for use for 10,000. Green Energy Limited believes that it can install electricity producing solar panels on the land. The total cost of development will be 85,000. First, at time 0, if you see, it is 10,000 initially. Okay, that the piece of land is available. Now let's come to our question sheet which they provided. It has been given from year 1. So at the end of year 1, basically, it's not time 0. If it start at year 1, if we see that at the end of year 1, the value of the land purchased will be nothing but 10,000 into 1 plus I, and I is given to us at 6.5% in the question itself. Okay, so I've written I over here. This is coming, it's getting calculated. This will get calculated 10,000 into 1 plus before 1.65%. Okay, then we have the installation cost, which is nothing, which they have been mentioned in the question, that the total set of development will be, cost of development will be 85,000. This cost will be paid monthly in advance in 6 installments. Equal installment. The first payment will be made at the same time that the land is purchased. At time 0, the first payment is made, so it's in advance. Electricity production will start 6 months after the land is purchased. First, let's only to focus on the cost of developments. 85,000 the cost of, and will be paid monthly in advance in 6 equal installments. So what is the values we are paying here? We are paying 85,000. Now it is monthly, so into 12. because 85,000 will be paid monthly, into B5. B5, what is you have calculated is SDU 0.5, SDU 12.5. Now, why we have calculated this is because only for 6 months the payments are being made and it's being made monthly. So we need to calculate SDU 12.5, and that formula is 1 plus I to the power 0.5 minus 1 divided by I12. Sorry, D12. Okay, because it's SDU, so we need a D12. And once you have D12, we just multiply this. And then we divide it by 6 because only 6, because this payment has been made over 6 months. So it needs to be equally divided into 6 months. So 85,000 divided by 6 into 12 because of the monthly payments into this SDU 12.5 into, now this is for this, whatever we have calculated, we have accumulated it till the half year, 0.5. This value SDU 12, 0.5 accumulates it, the values till half year, but we need it till the end of the year. So we'll again multiply this with 1 plus I to the power 0.5 to accumulate it till the end of the year. Okay. Then we have, it is electricity prediction will start 6 months after the land is purchased. So basically we start at 0.5. It is estimated that developments will produce at 80,000 of units of electricity per year, with the production assumed to be uniform each year. Green Energy Limited will sell the produced electricity to the National Power Limit supplier at 0.12 per unit. Payments of electricity produced will be received quarterly in arrears. So basically units generated for the first year starting from 0.5 till 1. So for half year, it is generated only 40,000 units. For next year onwards, it is generating 80,000 units. And it is now, if you see, the level of electricity will fall and the zonal panels will start to degrade. It is estimated that the level of electricity produced will fall by 0.5%. Okay, occurring 6 months after the production begins. So first time production begins, it will not decrease. After 6 months, that is at the end of year 1, beginning from year 2, the production starts degrading. So it's degrading by 0.5%. So we'll write 80,000 into 1 minus 0.5% to the power time from 1. That's first time. Don't do it from time 2. It starts decreasing 1 time a time each. Okay. Now we have price is fixed 0.12. Okay, price is fixed. Now green energy, now they've said the level of this is there. So now income, what will be income? Income will be, if we see, 40,000 is what we have received in the first year. Into, since it's received quarterly in arrears, we'll multiply it by 4. Okay, into G14 is nothing but the price we have. Then we have, now we have this for half year. So we need to calculate half year accumulation value, which is nothing but 1 plus I to the power 0.5 minus 1 and divided it by I4. We'll accumulate this entire thing, the next part of the year, from 6 to 12 months for half year. So this is the half year accumulation we have done, 1 plus I to the power 0.5 minus 1 divided by I4, because payments are made quarterly in arrears. And then the whole thing is divided by 2 because we have done, this is half yearly payments being done. So this is the whole divided by 2, 0.5. Yeah, payments are being done half yearly in the first case. For the next case onwards, for the next case, full year payments will be done. So this is 79600 is for full year. So this is nothing but calculate 79600.12 into S41, which accumulates a value of quarterly payments at the end of each year. This will accumulate the payment at the end of each year, not at the end of the last year, but at the end of each year. Okay, values at the end of each year. And then we have the maintenance cost. Green Energy will start maintenance work after 6 months of electricity production. That is 6 months after, that is at the end of first year, 0. Yeah, from year 1. The maintenance costs are expected to be 1,000 per annum incurred monthly in arrears. So once monthly in arrears, that means yearly if also we start in arrears. That means at the end of year 1, at the end of year 2, we'll start calculating maintenance costs. Annual maintenance costs will increase by 3%, with the first increase taking place 1 year after the maintenance work starts. So here, after 1 year after the maintenance work will start, first year maintenance works will start over here, which is 1,000. into B7. B7 is nothing but S12 1 because payments are incurred monthly. So S12 1 and into 1 plus 3% to the power time minus 1. So first year there will be no increase. From next year onwards there will be increases. Okay. And this is happening in arrears. So we have taken values in arrear. So from time 0 to time 1, there are no maintenance costs. So time 1 to time 2, there are maintenance costs happening monthly in arrears. So we have put it over here from time 1 to time 2 at the end of year 2. Now income is now the profit is nothing but income minus purchase cost minus installation cost minus maintenance cost. This is our profit for the all the cash flows. Okay, so the annual cash flow for income and outgo is done. Now next part says determine the accumulated profit after 30 years. So accumulated profit for first year, this will be the profit. For next year, the profit becomes, now we'll take out each value to the end of next year and then add on this value. So I've taken 95160 to the 1 into 1 plus I plus next year's profit. This is something like loan schedule we are performing. And last value 42671 remains. So this is the accumulated value at the end of 30 years, 42671. And projected is the accumulated profit first becomes positive. So we have done becomes positive. I made one column over here. If and I see first value J13 is less than 0 or J14 is greater than 0, we take up the time. Otherwise, he'll remain blank. So this is positive, this is in. So we get a time. And we take a maximum of this entire column. So the first time the cash flow becomes accumulated profit becomes positive is at time 25. That is at the end of 25 years. Okay. Now the local government has decided to offer an incentive to new generators of renewable electricity. The incentive will be provided at the rate of 0.1 per unit of electricity produced in the first 5 years of electricity production and will be payable at the end of every 6-month period. So it's payable half yearly. So we need to calculate half yearly data as well. So we'll calculate half yearly as half 0.5 and S2 1. Now why we calculate S2 0.5 is that the time of incentive for first year, since only half year electricity production was made. So this is only half year electricity, then 1 year, 1 year, 1 year, 4 full years, and then half year, half of the 6th year. Okay, the payment will be made. Then only it will complete 5 years of full payment. So incentive is 4,000. How we have calculated 4,000 is 4 by 2, that is 4 payments in a year. So it said 0.1 and will be payable at the end of every 6-month period to offer this. Okay, so this is 4 by 2, 4 into, because of the quarterly payments of the electricity produced will be quarterly. So this was quarterly into units will be units of quarterly 4 by 2 we did into 0.1. 4 is quarterly payments, 2 is because it is being received semi-annually, into 0.1 is the rate of the incentive, into B9, F19 is the unit generated, into B4 is S2.4, accumulating it for half year. Now for next year, it is nothing but units generated into 0.1 into S21, accumulating it at the end of the year. And now for last year, it is nothing but units generated into B4 for half year into 0.1 into, now this is half year in the mid of the year, not at the end of the year. We need to take it to the end of the year. So 1 plus I to the power 0.5 is required. Okay. Then accumulated profit remains again the same formula how we have done previously, and then we'll see becomes positive. Now if we see the value becomes positive at time 12, it becomes positive at time 12. Now the question asks us what is the impact on this, how your answer will change. So answer will change by exactly half year. So payments will now the profit will come faster once the government starts giving an incentive. Okay, and it will be much higher as well. If you see total profit accumulated as such will also increase. 256,614 and here it's 42671. Okay. Then we have, this is adjusted over here. Incentive is added over here in the cash flow. Okay. So once this is done, now we have the third part, comment on the suitability of the model and assumptions used by Green Energy Limited. So model is suitable if we see that there are positive cash flows. Since we are receiving positive cash flows, that means the model is suitable. If there were no positive cash flows, assumptions is that the all the values are assumed to be constant. There is no assumption of inflation, or there is no assumption of any other changes of interest rates or anything. It might happen that the all costs do not work on the same interest rate and they have different interest rates. So this assumptions and suitability of model will depend on the data given in the question. All of you can go through the paper and see the marks allotted which you all can get through this paper solving, and what is the type of marks you are getting, so that it is better for you to prepare for the next paper if required, or if this is good okay or not. Otherwise, this paper was a good paper. Only thing that this question might take and might have taken up a lot of time for all the students, but if somebody had written the equation on the first hand writing, then it would be easier to solve this paper. Thank you, everyone.